In this video, we are going to talk about derivatives of trig functions. And we're going to start with sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And we are going to prove one of these. They both work the same way, so we're just going to prove one. Let's show that the derivative of sine is equal to cosine. So we're going to start with that limit definition. Limit as h goes to 0. So it's f of x plus h. So we're going to plug in x plus h for that x, minus f of x, which is the original function. We're going to divide by h. So our next step is going to be use the sum formula for sine. So if you remember back to pre-cal, you had a formula to rewrite this. It was sine of u plus v equals sine u cosine v plus cosine u sine of v. So let's rewrite that. Now we have not taken the limit yet, so I have to follow that limit in. So I'm rewriting this. So this, applying this formula, would say sine of x cosine h minus cosine x sine of h. And then we still have that minus sign hanging out all over h. So now we're going to group some things together. Notice this term and this term both have a sign in it. So I'm going to factor that sign out. And that's going to leave me with cosine of h minus 1. And then we have minus cosine x sine of h. And remember, all of this is over h. Now we're going to do some fancy math. I'm going to split that numerator. That's one of our tricks that we can use. So this is sine of x times cosine of h minus 1. I'm going to rewrite this as two different limits. I'm doing two steps in one here. So I split that numerator. I know the limit of the difference is the difference of the limits. And now let's analyze this a little bit more. Notice that I'm taking the limit as h goes to 0. So h is my variable I'm concerned with. This sign has nothing to do with that. So I could treat it like a number and I can bring it out. This is cosine of h minus 1. Same thing here. I can pull that cosine out, treat it like a number. And this is sine of h over h. And then now we're going to use our calculator. We don't really have a good definition for what's happening here and here. What we know is that I can't plug in 0 because I get 0 over 0. So now I got to figure out what is that limit going to be. We could use that table feature in our calculator, and I encourage you to do that. Plug this in your function. Look at what happens when we plug in negative 0.1, negative 0.01, negative 0.001, and then come in from that right side at 0.1, 0.01, 0.001, and you'll see this guy is going to 0. If we do the same thing here, we're going to see that this is actually going to 1. So what we're going to have here is sine of x times 0 minus cosine of x. Oh, hold on a minute. Why do I have a minus there? I think I have messed up. This is a plus, so this guy should be a plus, which means this would be a plus. Let me correct my signs here. Sorry about that. And then now I have cosine of x times 1, which is just going to give me cosine of x. So we just showed that the derivative of sine is equal to cosine. And we would do the same thing if we wanted to prove this one. We would end up using the sum and difference formula for cosine of x plus h. And that's where that negative is going to come from in there. And you'll see those two special limits come out again. Let's look at tangent and cotangent, and we'll prove one of these. Let's say we want to prove that the derivative of the tangent of x is equal to secant squared of x. So we're going to write this. We want to take the derivative of tangent. We know that's sine over cosine. And this is going to be a quotient rule. Quotient rule says it's the bottom times derivative of the top. Now I'm not taking the derivative yet. I'm setting up minus the top times derivative of the bottom. So here's my setup over the bottom squared. So now let's take the derivative of these two pieces. So we have cosine x times the derivative of sine, which is cosine x. And then we have sine of x times the derivative of cosine, which is negative sine of x, all over cosine squared. So this ends up being cosine squared plus sine squared in the top. And that is a Pythagorean identity. We know that is equal to 1. So now we have 1 over cosine squared, which is the same thing as secant squared. And then let's prove one of these. Let's prove that second one. We're going to prove that the derivative of the cosecant is equal to negative cosecant cotangent. And it's going to prove the same way. Cosecant is the same thing as 1 over sine. So we're going to use quotient rule. Quotient rule says it's the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. So this is my setup step. Now I'm going to take derivatives. Sine of 1 is 0. The derivative of 1 is 0. The sine derivative is cosine over sine squared. That's 0. So my numerator is just negative cosine over sine squared. And I could think about this as negative cosine over sine times 1 over sine. That is algebraically the same thing. Negative cosine over sine is negative cotan. 1 over sine is cosecant. And we could rewrite that as negative cosecant cotangent. So let's look at a few examples where we're going to apply these rules. Let's say we have y equals x squared minus secant of x plus 1. And we want to take the derivative. We're going to take the derivative of each piece. Derivative of x squared is 2x. The derivative of the secant is secant tangent. And the derivative of 1 is 0. So look at another one. What if we have the derivative of sine of x, tangent of x? So this is a product rule. So we're going to set it up. Product rule says it's the first times derivative of the second. So this is my setup step. Plus the second times derivative of the first. Derivative of the tangent is secant squared. Derivative of the sine is cosine. So that would be my derivative.